Namaste. Welcome to the next video of Machine Learning Techniques course. In this video, we'll implement random forest from scratch. Random forest is a bagging technique that trains multiple decision trees with minor modification in split criteria. So here you have decision tree on the left hand side and random forest on the right hand side depicted with a figure. In case of decision tree, we train a single decision tree, whereas in case of random forest, we train multiple decision trees on different training sets obtained through bootstrap aggregation or bagging. Let's look at the random forest algorithm. We have training data D with shape n, m, where n is the number of examples and m is the number of features. There are following steps in the random forest algorithm. We first sample Q datasets, each of shape n, m from replacement from the original training set D. So now we have Q datasets D1, D2 to DQ. In each of the dataset Dj, we select U out of M features before each split and train a full decision tree classifier or regressor. The final predictor is for regression. We obtain an average output from Q regressors and that is assigned to the new example. For classification, a majority voting is taken and a class label with maximum number of votes is assigned to the new example. Let's turn our attention to the implementation of random forest. In order to keep the implementation focused to main components of random forest, we make use of decision tree classifier from scikit-learn library for decision tree classification component. If you are solving a regression problem, you can make use of decision tree regressor instead of the decision tree classifier. We import NumPy, pandas, counter from collection and decision tree classifier from sklearn.tree. We build a code component wise and finally combine them into a random forest class. Let's first implement the bagging component. Bagging creates Q bootstrap samples D1, D2 all the way up to DQ from the original dataset D. The key step here is np.random.choice with size equal to number of samples and replace equal to true, which ensures that the bootstrap sample has the same number of samples as the original training set and the bootstrap sample is obtained by sampling with replacement. Then there is a majority voting that is used in order to assign label to the new example. So here what we do is we find out the most common label among different labels as voted by Q different classifiers and the most common label is assigned to the new example. Then we create random forest class with the following default parameters: number of trees equal to 10, minimum number of samples to split a node equal to 2 and maximum depth of the tree equal to 100. And there is one more feature which is max underscore features is a configurable parameter that can be set by the user. In order to train the random forest classifier, we implement a fit method that takes feature matrix and label vector as input. We initialize an empty list of decision tree classifiers. In the for loop, we train each decision tree with parameter sets from the random forest on a bootstrap sample obtained through the bag function. Let's implement predict function for inference. Here we need to note that each tree gives independent prediction for individual rows in the input features. For example, if we have 3 trees and 2 classes 0 and 1 and let's assume the prediction for 5 samples is as follows. So tree 1 gives label 1 to example 1, label 1 to example 2, then label 0 to next two examples and label 1 to the last example. In the same manner we have output from label 2 and label 3. So we aggregate the output from the respective samples and take an average or majority vote. That is done through np.swapaccess function. And after performing this swap access, we call most common label and obtain label for each of the example from the random forest. Finally, we combine these different components and create a random forest class. We have two special functions, one for bootstrap aggregation or bagging. Then there is a most common label function that gives us the majority voted class label. And in random forest, we have a constructor, then a fit function that trains the random forest classifier as we have seen earlier, and then the prediction function for inference from the random forest. Let us demonstrate our random forest implementation on a real-world dataset which detects breast cancer. So what we do is we load the breast cancer dataset. We have the feature matrix and label vectors. We split the train and test set. We initialize a random forest classifier with number of trees equal to 10, max depth of tree equal to 10, and maximum feature equal to square root. So here we'll be using square root of m as maximum number of features for training individual decision trees. Then we call the fit function with training feature matrix and label vector as inputs. Then we obtain the prediction on the test set, and we obtain the accuracy of prediction on the test set. It turns out to be 0.947 or close to 95%. Let's look at the confusion matrix and classification report on the test set. So you can see that confusion matrix, there are 6 examples that are misclassified. So the precision for the class 1 is 0.92, recall is 1, and F1 score is 0.96. Overall accuracy is 0.95. Let's look at the heat map, which is alternative representation of what we saw earlier. So here the true label is 0 and actual prediction is 0. There are 36 such kind of examples, and there are 72 correctly classified examples from class 1. However, there are 6 examples with actual label 0 have been predicted to be 1, so these are false positives. So in this video, we implemented random forest from scratch, and for that we use the decision tree classifier from sklearn for decision tree implementation. We demonstrated random forest classifier on a breast cancer dataset.